If you have enough energy, you can make mass. The Bright-Wheeler process describes the mechanism of forming an electron-positron pair out of two photons. Photons have no mass and are waves of pure energy, while an electron and positron both have mass. The amount of energy required to do the conversion is huge, and the process is yet to be conclusively done in an experiment. However, most physicists agree with its principle and believe it is just a matter of time until it's demonstrated. Physicists Gregory Bright and John Wheeler based their predictions on Einstein's formula, E equals mc squared. It tells us that a large amount of energy is equal to a small amount of mass. It also infers that mass and energy are the same thing. Mass is a very concentrated form of energy, while energy is the dispersed version of it. Although smaller pieces make up an atom, you can think of it as the fundamental building block of your world. It has mass, but also can be thought of as concentrated energy too. An atom starts with a ground state level of energy and can take on bits of it to exist in an excited state. It is as though an atom is an energy storehouse. It is not only made of energy, but receives and subsequently ships it out too. Here you see a molecule of hydrogen made of two hydrogen atoms. It's also a storehouse. It has a rule that it only deals with certain energy packages. They must be the right size and a complete package only, no partials. Because it receives a specific quantity or quantum of energy, this property of atoms and molecules led to the entire field of quantum physics. When a molecule receives a quantum of energy or a photon, its characteristics change. For example, some photons cause the molecule to spin, and others cause the two hydrogen atoms to vibrate back and forth. There are many rates at which spinning and vibrating occur based on the oomph of the photon. Molecular characteristics also change when a molecule emits a photon. Here, the molecule is vibrating at a high frequency, and upon shipping out the photon, the vibration slows to a lower frequency. Molecules are constantly receiving and emitting energy, and all this would be otherwise pretty boring, but the movement of photons between molecules has great philosophical implication. Because molecules bounce off each other in predictable ways, their future direction and speed is also predictable. Not only is it predictable, it is determined. The position of a molecule in space at a future time totally depends on where it was a moment earlier. Because it follows the laws of Newtonian physics, it has only one place it can be. If all molecules have a determined future, it means that everything larger, that is, things that are made of molecules, which is everything, is also determined. Since the future is fixed, there is no room for free will. Your body is determined to choose chocolate ice cream, and you couldn't choose otherwise. This is where the receiving and emitting of quanta from molecules comes into play. Two colliding molecules will bounce off of each other in a predictable and determined way every time. However, if one molecule absorbs or emits a photon before they collide, the collision is altered. The future direction and speed of the molecules is different, and thus their future is different. If molecules can have a different future, then everything made of them can have a different future too. So what determines when a molecule receives or emits a photon? Quantum physicists say it is a random process. There is no hidden variable which has yet to be discovered. It is inherently random. Statistics give you an idea of the probability of when and where a photon will move, but can tell you nothing about a specific molecule. I believe what scientists see as a random event is actually a willed event. The choices you make cause the emission and absorption of photons. When you see vanilla and chocolate ice cream next to each other, your mind exerts its will. It decides. That choice causes gazillions of photons to redistribute, and subsequently, the molecules of your body bounce off of each other differently, creating a new future. It starts a molecular cascade that results in your mouth saying, "I'll have chocolate, please." Scientists see the when of photon emission and the where of its absorption as random occurrences. When dealing with the when of energy emission, they discuss the event in terms of half-life. This means that 1/2 of the population's molecules will have emitted a photon by a certain time. On the other hand, a Gaussian curve communicates the where of photon absorption. For example, here's the distribution of photon absorption after many pass through the slits of the famous double-slit experiment. The picture shows the where of the photons that pass through the slits, but it is impossible to predict the where of the next one. I think the when and where of photons isn't random. They move between molecules by the exertion of will. Most of the time it is God's will, and occasionally when you focus on a decision, it is yours. You are the one that consciously chooses chocolate ice cream, but God keeps your heart beating, the wind blowing, and the sun shining. Am I saying that God's will is moving photons between all 10 to the 80th molecules of the universe? Yes, and He has been doing it since the beginning of time. It is a mind-boggling amount of events He has supervised. He has moved every photon through every double-slit experiment ever performed and put it exactly where He wanted. That seems like a lot of effort on God's part. So why does He do it? He does it for you. All the quanta He moved in the sun and stars today was for you. I think I did something great by getting my wife some flowers for Valentine's Day. It's nothing compared to what He's done for you every day. Keep thinking, and I look forward to your feedback. Please leave your comments and questions below or contact me at my email address. Until the next video, remember humility, thanks, and joy.